So in today's session, I will discuss semi-converter. Like last previous session, I have discussed full bridge converter. So semi-converter, these are the three possible configurations. Like any of this circuit will be there in the question, then we can consider that as a semi-converter. Okay. So one by one, I will explain all the circuits. This circuit is called as symmetrical configuration. This is asymmetrical, and this is full bridge converter with the freewheeling diode. So for all the circuits, output voltage will be same. The formula will be Vm upon 2 pi 1 plus cos alpha. So this output voltage formula will be for all the configurations. Okay. So one by one, I am going to draw the currents and voltage waveforms. Okay. So this is the first configuration, symmetrical configuration. So input voltage I am taking at Vm sin omega t. Okay. So T1 will be fired at alpha, and again 2 pi plus alpha, and T3 will fire at pi plus alpha and 3 pi plus alpha. So we can say that the firing angle of this converter is alpha. Okay. So input voltage will be like this, Pm sin omega t. What will be the output voltage? So all the configuration I am assuming output current as constant, ripple free. Current I am assuming as ripple free. So I naught is ripple free, constant. Okay. So here I am firing this T1 at alpha here. So T1 will fire means what will be the output voltage? This D2 will conduct, D2 will be forward bias. So T1 D2 will conduct, and output voltage will be like this. Waveform will be like this. Again I am firing this T3 at pi plus alpha, but out this current is constant, so current needs some path. Okay, so before this, what will happen? This current will follow this path, this one. T1 is fired already, so T1 and D4 will conduct. Okay, so T1 D4 will do the freewheeling here. Output voltage will be 0 in this section. Okay, again here T3 D4 will conduct, so waveform will be like this. Alpha, this is pi, this is pi plus alpha, this is alpha, and this is 2 pi. Okay, so this is the output voltage. Is it clear, or should I explain again? VO waveform. Again I will explain one. See, we are firing T1 at alpha. Okay, so T1 D2 will conduct. T1 D2 will conduct, and when T1 D2 will conduct, this is the source voltage and this is the output voltage. So T1 D2 will conduct, VO will be equal to VS, and here at pi, what will happen? Uh, uh, like we are firing this T3 at pi plus alpha. Okay, but this needs like output voltage is becoming negative here. So negative means this D4 will be forward bias. See here minus will come means D4 will become forward bias, and what will happen? T1 and D4 will do the freewheeling. Since current is there, it requires some path. So this current will follow through this path, D4 and T1. Okay. So if this will happen, this will output will be sorted and output voltage will be 0. Again at pi plus alpha we are firing T3. So T3 and D4 will conduct here, and T3 D4 will conduct means output will be equal to minus Vs. Okay. And again at this section T3 D2 will conduct. T3 D2 will conduct. And here which one is conducting? T1 D4. T1 D4, and during this section T3 D2. Is the waveform is clear to all? One can ask doubt. I will explain again. I will redraw the waveform again. Can anyone reply?
Sir,
Yes, please.
sir, can you explain again?
Okay, 1 second. I'll redraw again. I'll redraw trace waveform. 1 second. So One second.
Sir,
Yes, yes.
sir, what is the objective of this circuit?
This is a AC to DC converter. Okay.
AC to DC. Okay, sir.
So input side we are applying AC voltage, output will be DC. And this circuit is a called semi-controlled converter. Okay, semi-controlled
Semi
full grid rectifier. Okay. So
rectifier.
three circuits are there. See, single phase semi-controlled converter, semi-controlled or half control converter. So these are the three possible configurations. Okay. So one by one I will explain all these three circuits, and output voltage equation will be same for all. VO will be Vm upon 2 pi 1 plus cos alpha. Here alpha will be the firing angle. Okay. So first circuit I am explaining this one. So here one second. One second. See. So Vs I am applying source voltage, sinusoidal voltage. So this will be a sine wave. Okay. And first T1 I am firing at alpha is equal to 60 alpha I am firing. Okay. So what will happen at alpha? This is positive. Positive means here positive is there. T1 is in forward bias, and negative is there means D2 is in forward bias. Okay. At this side, if negative is there means D2 is forward bias, positive half cycle, and here positive is there means T1 is forward bias. So T1 I am firing here. So what will happen? T1 and D2 will conduct. If this will conduct, this plus will connect it to here, and this minus will connect it to here. So what will be the output voltage? T1 D2 will conduct, then output voltage will be equal to the source voltage. Okay. T1 D2 will conduct. Okay. One second. Again,
Sir,
yes.
sir, here might be possible D4 is also conduct. How we
That
can judge?
see in steady state we can write that waveform. Okay. See, I'm triggering at alpha only. So before alpha, nothing will be there. If we'll do the simulation of the circuit in MATLAB, so if you are firing at alpha, so output will come after alpha only, because before alpha the circuit was disconnected. Okay. But after 2 pi, we will get a steady state waveform. Okay. Since before alpha we are not firing, but we will consider every time steady state waveform only. So I will draw the steady state waveform. So that waveform will come after 2 pi. So same waveform I will draw in first cycle also. Okay. So we are firing at alpha. So alpha means T1 D2 will conduct. T1 D2 will conduct means output voltage will same as the source voltage. Okay. Now at pi, what is happening? So at pi, our voltage is becoming negative. So voltage is becoming negative means what will happen? This here it is becoming negative. So here negative means the D4 will become forward bias and D2 will become reverse bias. So what will happen, since we are not firing T3 before alpha, T3 we are firing here pi plus alpha. Okay. So before T3 what will happen, this current is constant current. So it needs some path. Okay. So see here D2 is, it will not follow this path since D2 is reverse bias. So since D4 is forward bias, it will follow this path. This current will follow in this loop. Okay. So if it will follow in this loop means this point and this point is sorted. It means we can say that the output voltage here is 0. So here to here output voltage will be 0. Again at pi plus alpha we are firing this T3. So T3 will start conducting and T3 D4 will take the current. So T3 will start current means taking current means it will follow like this. It will come, current will come like this. It will follow in this one like this. So if it will happen, output voltage will be minus of Vs. Okay. So output voltage will be like this. Here it will be 0. So 0 to alpha to pi, which switches are conducting? T1, D2. Here freewheeling will happen, which will do T1, D4. And here
T3 and D4.
T, T3, D4. And again here freewheeling will happen. So freewheeling which will do T3, D2. So here also we can say that T3, D2 is conducting. Just by assuming that steady state, Here T3 D2, and here also T3 D2. Is it clear? Is it clear?
Yes, clear now.
Okay. So now based on this, we can draw all the switch current and source current. Okay. So I'm going to draw IT1 and ID4. IT1 we can draw. So IT1 will be, T1 is conducting from alpha to here pi plus alpha. So here it will be alpha, pi plus alpha. And D2 where it will conduct? D4. D4 will conduct from pi to, wait 1 second, T1 D4 and T3 D4. So it will conduct from it okay. D4 is conducting from pi to here up to here. So pi to 2 pi. Is it clear to all?
Yes, sir.
This is IT1, this is ID4. So what will be the source current? Source current will be IT1 minus ID4. Okay. So source current will be alpha to pi positive, and this will be negative. So pi to pi plus alpha it will be 0. So alpha to pi and pi to pi plus alpha it will be 0, and here it will come as negative. So pi plus alpha to 2 pi. This is the source current. Okay. Here this is T1, IT1, this is ID4. So if you apply nodal here, so source will be IT1 minus ID4. So this is the source current. This waveform is clear to all? IT1, ID4 and source current. Net clear? So we can write
Sir,
that.
in this input voltage is sinusoidal, source of current is non-sinusoidal, that is square wave, sir.
Yes, because output current I am assuming constant, ripple free current. Highly inductive load. So approximately we are assuming if it will be written in the question, mostly this type of question only will come in the exam. So if it will be either written highly inductive load or ripple free current or stiff current. Okay. So that case I am analyzing. I am assuming that this current is constant. So this current is constant means input side also a square kind of waveform will come. Is it clear?
Okay, sir. Output current is constant, sir.
Yes,
Straight line.
assumption is a straight line. Output current is constant. So when that will happen, that will happen in case of highly inductive load. Okay, in question if it will be written highly inductive load or ripple free output current, okay, or steep output current, all will be a same meaning. So we can do analysis like this. Okay, so from these waveforms we can calculate the RMS current and average current of the switch and source current. Okay, so IT1 RMS will be IT1 RMS or IT3 RMS will be I naught into this amplitude will be I naught. Okay, this magnitude will be I naught. Here also this magnitude will be I naught. So I naught into pi plus alpha minus alpha divided by 2 pi. So it will be I naught by root 2. And ID4 also it will be same, 2 pi minus pi, so it will be pi. So ID4 will be I naught into pi by 2 pi. So it will be I naught by root 2. Is it clear? So question it will be asked like that, some question will be given and their output current will be given. So it can be asked like what will be the RMS current of the switch or diode. Anything will be, both will be I naught by root 2 for this case. Is it clear?
Yes, sir. For source
Yeah.
current, IS into under root
Source current will
pi
be,
minus alpha by 2 pi, sir.
see. So this is alpha to pi. This is also pi plus alpha to 2 pi. So in 2 pi, it will conduct for 2 into pi minus alpha. So 2 into pi minus alpha divided by 2 pi into I naught. So source current RMS will be pi minus alpha by 2 pi into I naught. Okay. So for average, what we can do, average same formula will be there. Just this a square root will not be there. Average just total conducting period divided by conducting period divided by total cycle. So average will be just a square root we will remove, then that value will be the average value. Is it clear? I think all of you know that short tricks, like how to calculate a square and RMS of a straight line kind of waveform. Is it clear to all?
Sir, clear, sir.
Okay. So these things are required, and average voltage we can derive, like VO average will be alpha to 1 second. So VO average will be 1 upon 2 pi. On upon pi we can say this period is pi, 1 upon pi alpha to pi Bm sin omega t d omega t. So is it clear this equation? See, periodically it is a pi only, alpha to pi. Okay. So Vm upon pi 1 plus cos alpha. This will be the waveform. This will be the average value of the output voltage. Is it clear? I think all of you know this formula.
Yes, sir.
Okay. So coming to the next configuration. So 1 second. This is the third one. Second one I will draw first. So
Sir,
second, yes, you can ask.
in previous question, if there is a freewheeling diode, what will be,
Huh,
sir?
huh. Same thing will happen. Then freewheeling diode will take care. This will not take care. Freewheeling diode will take care. So that will, since this thyristor is there, so thyristor it
But your
requires.
waveform changes now, sir.
Waveform will be same. Output waveform will be changed, but this current waveform will be changed. Okay. Output voltage waveform will be same. Since this will conduct, then also output voltage will be 0. That we will do. I will analyze whatever you will ask, that circuit I will analyze. Okay.
Okay, sir.
Sir,
Yes.
RMS value of output equal to
No,
average
no,
divided by root 2
no, no. Which RMS you are asking? Which waveform?
output.
Which output voltage or current?
Output voltage.
Voltage we can derive now. That basic formula we can apply. Okay. That RMS
Sir,
formula 1 by
sir,
T
but
xt
uh,
square dt. You should go by that formula. What you are asking?
sir, this is the rectifier circuit, and in output we are getting DC voltage. Sir, there is concept of RMS in DC value.
See, RMS means for any waveform we can calculate RMS or average. What is RMS? For any waveform, RMS or average we can calculate. See, this is the waveform. This is the waveform. So for same waveform we can calculate either RMS or average. Is it clear?
Yes, sir. Either it is DC or AC.
Anything we can calculate. This waveform is there. If you'll do the Fourier analysis, it will have some DC value also. It will have harmonics also. Okay. So same waveform, like let's say sine waveform. I'm taking sine waveform. So sine waveform, average value will be 0. See, this sine waveform I'm taking, the sine waveform average will be 0 because positive area is equal to negative area. But it will have some RMS value. Okay. What am I doing? I'm shifting this sine wave. Like let's say DC shifting I have done. Okay. So for the same waveform, this positive area will increase, negative area will decrease. So it will have some DC value also and some RMS value also it will have. Is it clear? DC means what? Average
Okay,
value.
sir.
Okay.
Okay, sir.
Okay. So coming to the second circuit, 1 second. So second configuration will be like this. And this side diodes will be there. Okay. So this is T1, D2, D3 and T4. And here also I'm assuming constant load current, stiff load current. Okay. This will be the source voltage. Okay. So we are firing T1 at alpha, here also same. 1 second. 1 second. 1 second. So here also we are firing T1 at alpha. So this is source voltage. Okay. Again we are firing T1 at alpha. So which will conduct? T1 D2 will conduct. So here to here T1 D2 will conduct. T1 D2 alpha to pi T1 D2. At pi what will happen? This D3 and D2 will do the freewheeling, pi to pi plus alpha. So here to here D3 and D2 will do the freewheeling. So D3 D2 will do freewheeling means output will be 0. Again here to here we are firing T4, so T4 D3 will conduct. So here to here T4 D3, again here D3 D2. So this will be the waveform. Okay. Output is same, so voltage will be same, Vm by pi 1 plus cos alpha. But our thyristor and diode current will be different here. Okay. So that also we can draw. T1 current will be, T1 will be conducting where to here? Alpha to pi. So I T1. T1 is conducting from alpha to pi. Alpha to pi. And T4 pi plus alpha to 2 pi. Okay. So source current will be also same here. IS. IS will be same. IS will be same in all three cases. Okay. So alpha to pi. And this will be pi plus alpha to 2 pi. Is it clear? Output voltage waveform first I will explain again. Anyone can ask? Hello?
Sir, IT1 means pulse
No,
is given to the thyristor.
No, IT1 means current through this thyristor. Okay. IT1
Okay.
means current through this thyristor, and this is IT4. So this is current through this thyristor, and IS is the source current, this blue color waveform. Okay. So here to here, since here from here we can see that T1 is conducting from alpha to pi. So alpha to pi, this load current will flow through T1. Okay, when T1 will conduct, then load current will flow through T1. So we can write like this one. I0 is flowing from alpha to pi. Similarly, when T4 will conduct, so T4 is conducting here to here. Okay, T4 D3. So this is pi plus alpha to 2 pi. So pi plus alpha to 2 pi, this current will present here for T4. Output current will be shared by this T4. Okay. So what is the source current? Here we can apply the nodal. So same as previous case, source current will be IT1 minus IT4. So this will be the source current. Okay. So what will be the IT1 RMS here? It will be I0 into pi minus alpha by 2 pi. In previous case, it was I0 by root 2. Simply it was I0 by root 2. But here it is I0 into pi minus alpha by 2 pi. And IS will be same. IS is equal to I0 into pi minus alpha by pi. Same as previous. Because waveform is same. Okay. And what will be the diode current? If we'll see, let's say D2 current I am seeing. So D2 we can see that D2 is conducting from 0 to here pi plus alpha. Okay. This is pi, it is pi plus alpha. So we can say that diode D2 is conducting for pi plus alpha. So D2 RMS will be pi plus alpha divided by 2 pi into I0. Is it clear to all? Once again I will explain. Anyone can ask. If anyone have doubt in output waveform also, I will explain again how this diode and thyristor configuration are conducting. Is it clear?
So for D3 also same formula, sir?
D3 also same. See how D3 is conducting here, here and here. In one cycle, here it is for alpha, here to here, and here to here, pi. Okay. So we can say that in 2 pi cycle, it is conducting for pi plus alpha. This is pi and this is alpha. So in
Okay.
So D3 will be same only. Is it clear? I think it will be clear to all. Okay.
It's a clear, sir.
Okay. So I will do third case. So third case is this one. Okay. Normal full bridge rectifier with a freewheeling diode. Okay. So here also it will be same. Waveform output voltage will be same. Okay. At alpha I am firing T1 and T2. So output voltage from here to here will be Vs. Again at pi this will become reverse bias. So we are firing T3 T4 here pi plus alpha. So here to here this current will flow through this freewheeling diode like this one. So output will be 0 and voltage will be here to here. So alpha pi plus alpha 2 pi. So alpha to pi which will conduct T1 T2 pi plus alpha to 2 pi T3 T4 and here remaining section freewheeling diode will conduct. Here also freewheeling diode will conduct. Okay. So source current we can draw here also. Source current will be same only. First IT1 alpha to pi and IT4 pi plus alpha to 2 pi and IS will be same as previous. Okay. This will be IS waveform. So it will be here to here alpha to pi and this will become negative pi plus alpha to 2 pi. Is it clear?
Sir, for IS, IT1 minus IT4, sir.
Yes, sir. IT4. This is IT4. So here we can say this is entering current, this is going here, this is going here. So we can say that IS plus IT1, this should be IT4 should be equal to IT1. So IS should be equal to IT1 minus IT4. Is it clear?
Oh,
This
yes,
is
sir. Yes, sir.
so nodal we can apply here. The simple nodal equation. Okay. And we can one thing we can observe that two things are same in all things like output voltage, okay, and source current. See here, output voltage is this one, source current is this one. Here also output voltage is this one, and source current is this one. Okay. And for another one more case was there. Second. Here also output voltage and source current is same. So where we are getting the changes will be there in the diode and thyristor current, but output current and source current and output voltage will be same. So input power factor and THD definition, and it will be same for all the configurations. Okay. Only if they will ask either diode or thyristor current, then only we have to be careful. Otherwise, only one formula will be there for all. This is the source current formula. It will be common for all, and output voltage Vm upon pi 1 plus cos alpha. It will be also common for all. Is it clear? So now I will do the Fourier analysis of this waveform, source current waveform. Okay.
Sir, can you explain the concept of firing angle and extinction angle and conduction angle for this waveform?
See, firing angle means here at this instant we are putting a firing pulse. So firing pulse means it will be a current signal to this gate. So firing angle means at an instant. At this instant, if we are applying a pulse, that will be a very small pulse. So that will called as firing angle. Means at that angle we are firing the thyristor. Okay. And conduction angle means for how much time it will conduct. So conduction angle means here to here. Okay. Conduction will be for T1. Let's say T1, what will be the conduction angle in one cycle? So conduction angle will be pi minus alpha. Okay. No, here T1 is conducting for pi minus alpha. Yes, pi minus alpha. And extinction angle means at pi. At pi, this current is this thyristor current becoming 0. So that will called as extinction angle. Means that at that time the current will become 0. Is it clear?
Sir, at that time, voltage is 0 now, sir.
Now current also 0. No? Here you can see.
Oh, okay.
It is conducting alpha to pi. This thyristor T1.
For thyristor, sir.
Yes. Thyristor T1 one. Firing angle alpha pi is equal to alpha. Alpha we are firing. Conduction angle will be conduction duration we can say. So here conducting from pi to alpha. So we can say that pi minus alpha is the conduction angle. Okay. And extinction means at that point it is getting the current will become 0. Okay, so that is pi. Is it clear?
Yes, sir, clear.
Okay, okay. Okay, so next thing what I am going to do, I will do the Fourier analysis of this source current. Okay, so this is the source current. Okay, so can anyone tell it is even or odd signal? The source current waveform. Same thing I have drawn in here also. Okay, just a repetitive kind of thing in LHS also. So is this a even or odd signal?
Sir, hard signal, sir.
No. What is the odd definition of the odd signal?
F of x equal
Except
to
X
x
of
of t equal to minus of
x of minus t should be
x
equal
of
to
minus
minus
t
xt.
minus of xt.
xt.
So this is not possible here. See, this is starting from here. Symmetry is not there. Okay. So
Okay,
what
sir.
I told for Fourier analysis, what is the first step? First step is we should make the signal either even symmetry or odd symmetry. Okay, anything we can do. So what I'm doing here, we can easily make this odd signal. Here to here alpha, if I will shift this angle at here alpha by 2, okay, so it will become a odd signal. So shifted waveform I am going to draw. So it will start from alpha by 2. Okay, alpha by 2 pi minus alpha by 2. Okay, and here also it will shift. This side, this waveform will be there. So now if we'll see, if we'll apply odd symmetry, it will follow. X of minus t if we'll do, this will go at top. So here to here and here to here distance are equal. Now it is a symmetrical waveform. Okay. So this, let's say this is x2 of t. So this we can say that this is a this will follow half wave and odd symmetry. Is it clear? This waveform. So what
Okay, sir.
so last class also I have done the same thing for full bridge converter. So we can say that this is x1t. Okay. So x1t we can write that as x2 of t minus alpha by 2. Is it clear? This will well. No? So what is the steps for Fourier analysis of source current? First we will do shifting, make it either even or odd. Then we'll do Fourier analysis of this one. Then what will be the Fourier equation? That will be shifted by this one. So x1t, we want Fourier of x1t, but we have shifted it and like we have derived the Fourier of this one. So Fourier of this one will be this one Fourier shifted by this one. Okay. So I'm going to write the Fourier equation, and Fourier also will be simpler. So 4 by pi, 4 by 4 by t, 0 to t by 2, xt sin n omega t dt, bn. N will be 0 since it is a odd. Okay, so only bn will be there, and bn also if it will follow half wave and odd symmetry, so the Fourier formula will be this one, 4 by t, 0 to t by 2, xt sin n omega t dt, and omega will be 2 pi by t, so time period is 2 pi, so it will be 1. Okay, so now simply we can write bn value. Bn will be 4 upon t, this is t, 4 upon 2 pi. So 0 to t by 2, so it will be 0 to pi, 0 to pi. This will be I naught. So I naught sine omega is equal to 1. So sine nt dt. Is it clear up to now? Is it clear to all? Bn value. Last also.
No, sir.
See, normally
How did you write?
Normally Bn formula will be Bn is equal to 2 by t. You know A and Bn, Fourier analysis. You know that concept, signal system. Any
Yes, sir.
see any
X of t into sin n omega naught t dt.
so xt sine n omega t dt. This is the normal formula. But if the waveform will have the some symmetry, like here this waveform will have odd symmetry and half wave symmetry. Okay, half wave means xt minus t by 2 equal to minus xt. This kind of symmetry is also there. You can verify. If you'll shift by t by 2, then this symmetry will happen. Okay, so if this two symmetry will be there, then bn will be this one. This will be the bn. Okay, short trick. This is a short trick. If we'll integrate full cycle also, then also we'll get same. But if symmetry will be there, we can do integration for this like this only. Same value will get. If you want, you can integrate the full cycle. That also you will get the same final output. Okay, is it clear? So this is a short trick. If symmetry will be there, in
Okay,
case,
sir.
is it clear?
Okay, sir.
Okay. So see, a final formula we can derive easily. So this is
Bn integral, sir. That one 0 to all pi. Oh,
uh,
sir.
so
Sir,
this
limit al
yes.
alpha. Yes, sir.
I'll
Alpha
write. So 2 I naught by pi, here we can write, and integral will be pi alpha by 2 to alpha
2
by 2
to
to pi minus
pi minus alpha by 2.
alpha by 2. This will be sine nt dt. Okay. So this will be 2 I naught upon n pi. This will be minus cos nt alpha by 2 to pi minus alpha by 2. Okay. So this will be the value of the bn. Okay. So bn will be, this will be 2 I naught upon n pi. So this will be minus cos n pi minus n alpha by 2. 2 I naught upon n pi minus cos n pi minus n alpha by 2, and second term will be plus cos n alpha by 2. Plus cos n alpha by 2. Okay. So if you'll observe this waveform for n is equal to 1, 3, 5, this will give 4 I naught upon n pi cos n alpha by 2. N is equal to 2, 4, 6. So this value will become minus only. So minus minus will cancel, minus plus will cancel. So it will be 0.
0.
So here also from waveform only we can say, since it is a odd and half wave, then 2, 4, 6 will be 0. Half wave symmetry will be there, then only odd harmonics will be there. Okay, even will be 0. So here we are getting the same thing with Fourier. So what will be the value of ISN, nth harmonic? ISN will be 4 I naught upon n pi cos n alpha by 2 sin n omega t. So n omega t will be for this waveform, but we have to calculate for this one. So for this one we can write as sin n omega t minus n alpha by 2. So this is the final waveform, Fourier source current. Okay. It clear to all? Is it clear? So last for full wave rectifier, this was not there and here alpha was there. Okay. Is it clear to all? This waveform?
Yes, sir. Clear.
Okay. So for this one, we can write fundamental also. So since this is ISN, so ISN is equal to 4 I naught upon.
So for semi,
This is semi converter only for. Yes, you can ask. You can
sir,
ask.
for semiconductor alpha by 2, sir, there will be.
So I will. This is the fundamental waveform. Okay, it will be shifted by alpha by 2. Why alpha by 2? So this is the waveform. The fundamental will be from here, like it will be here. This will be the fundamental sine wave. Okay. So since it is shifted by alpha by 2, this will be alpha by 2. This will be the fundamental waveform. Already we have derived this Fourier. So Fourier we are getting means it is shifted by alpha by 2. Why alpha by 2? It is clear from the Fourier equation. Anyone have doubt? Like why this is minus n alpha by 2? See, already this method I have told. If I want to do Fourier of this one, I will shift this waveform See, if you want to go do the Fourier of this one also, you can write A and B n separately, and you will derive all that will be a lengthy method. It will take 2-3 pages. Okay, but final you will come up on this only. Final will be this only. So what is the short method? First, that waveform either even or odd. So here I am making that waveform as odd signal. Okay. So I'm writing the Fourier for this one, but I need the Fourier of this one. But we have already this relation, x1t is equal to x2t minus alpha by 2. So x2t I know, so x1t I can write x1 of t. So x2t I have derived, same thing, minus alpha by 2 we can write here. So this will be x1t. It means the Fourier of the main source current. Is it clear now?
Yes, sir. Clear, sir.
Okay, okay. So ISN will be 4 I naught pi cos n alpha by 2 sin. So for fundamental n will be 1. So 4 I naught pi n sin omega t minus alpha by 2. Okay. So this will be the fundamental. What will the RMS divided by 2 root 2? So 2 root 2 upon pi cos alpha by 2 I naught. So this will be the fundamental source current. Okay. And what will the RMS value of the current for all the configurations? Pi minus alpha upon pi into I naught. So this two formula, no need to memorize. We can easily like draw the circuit and get these things. And another thing like distortion factor. So distortion factor will be IS1 by IS, and displacement factor here will be cos alpha by 2. Okay. So what will be the input power factor? Input power factor I have already explained. So IS1 by IS into cos alpha by 2. Is it clear? So at last class, what I will do, I will make a table. So table for all the configurations like single phase, three phase, all will be summarized at one place. Then it will be more clear. Okay. Is it clear to all? Can I improve some questions?
Sir, clear, sir.
Okay. Okay. You see, very simple questions they have repeated in the gate. So first question, I think this is 2018 question, 2018. Okay. What they have asked? They have asked the output current is constant. See what run by semi converter. If I naught is 20 ampere, so it means they are saying that I naught is 20 ampere constant. Okay, this I naught value. So this is the source current. Okay, so what the RMS value of the fundamental component of the current is? Okay,
I naught into root 2 by 3, sir, formula.
no. See, RMS value of the fundamental component of the current, not the this current. See, fundamental component means first like IS1. Okay, so already we have derived IS1 is equal to 2 root 2 upon pi cos alpha by 2 into I naught. Here already we have seen this
Okay, okay, sir. Got it.
fundamental value. Okay. If it will ask RMS value of the source current, see RMS value of fundamental component. So here if they will write RMS value of the source current, not fundamental current, then that will be IS RMS will be pi minus alpha by pi into I naught. That will be the source current, normal source RMS current. But RMS value of the fundamental component of the source current, and this formula we can apply. So easily we can write 2 root 2 upon pi into what is the alpha here? Alpha is 30 degree.
30 degrees,
So alpha is 30 degrees. So
30 degrees,
cos 15 into 20.
20 amp.
Can you calculate the value?
On root 2, 2 root 2 by pi means
2 into root 2 divided by pi into cos 15 into 20. 17.39 Newton is getting. See, so power electronics, what I will suggest you, they are asking very easy question. If you know the basic concept, easily you can get the marks from here. Okay. See, this is just formula based question. Easily 6 to 8 marks you can get from power electronics. Like just, it's not tough, very tough question they will ask. Okay. Is it clear to all? Everyone got the answer?
Yes, sir.
Yes, sir.
Clear, sir.
Yes,
Clear.
sir.
So see, next question also same question they have repeated in 2022. This is 2022 2 marks question, I think. See what is the difference? Same. This is the circuit semi-converter. So what I told, for all semi-converter, the source current and fundamental current equations will be same. Okay. So just they have given the circuit, different kind of circuit they have given. And what they are saying, the load current is 15 ampere and is ripple free. See, this is also one term, ripple free and constant current, all are same. Stiff current, ripple free current, or highly inductive load. So this current is 15 ampere. So what will be the RMS? See here one thing they have asked. So here we have to be careful. Amplitude they are asking. Sometimes they will ask RMS and sometimes they will ask amplitude. So if you will tick RMS value here, then that will be a wrong answer. And this is a fill in the blanks type question. Okay. So here they are asking the amplitude of the fundamental component of the source current. So what is IS1? IS1 is equal to 4 I naught upon pi cos alpha by 2.
Sorry, amplitude means maximum value, sir.
That only peak value. This value they are asking. Okay.
Okay, sir.
Amplitude means peak value. So amplitude they are asking. If you by mistake if you do RMS, because we know every time they are asking RMS. So this thing we should, like while doing the question we should read that carefully. Okay. Otherwise 2 marks question you will write the wrong answer. So 4 I naught upon a pi n pi, 4 into 15 divided by pi into cos, this is how much? Delay angle 45. So cos 45 by 2. And
So
anyone can
17.64, sir,
17.64.
amperes.
This one you are getting?
Yes, sir.
So see, this is 2 marks question. Just formula if you know, you can get just to like 20 seconds you can solve this question. Okay. Is it clear to all? Should I move to the next
Yes,
question?
sir. Yes, sir. Clear, sir.
Okay. Okay. So this is not a rectifier question, but already this kind of thing I have taught earlier. So like just a square wave is given. So this kind of a square wave we have already studied in the single phase full bridge. Okay. So what is the Fourier of the square wave? 4 I naught upon n pi sin n omega t. This was for the ISN source. A source current was the square wave in case of full bridge. But here what they are telling, a square wave voltage waveform is given. Okay. So what is the Fourier of the square wave? That will be 4 into, let's say this is V naught. So 4 into V naught upon n pi sin n omega t. This will be fundamental Fourier, any square wave. A square wave will be like this. Okay. So this is Fourier of the voltage. And what they are asking? Inverter is feeding a current of 10 sin omega t minus pi by 3. Okay. So I of t will be like this. It will be shifted by pi by 3. So what will be the power? Power will be Vs1 into Is into cos phi. Yet here why fundamental only? Because that frequency only will contribute the power. Remaining frequency, if you will do the averaging, that power will be 0. Is it clear? That I have explained in the first class. Right. Power will, when we will multiply to same frequency component, then only average power will happen. Okay. Is it clear? Is it clear to her? Otherwise I will explain again.
Yes, sir. Clear, sir.
Okay. So simple, like just multiply Vs1. So what is the Vs1? 4 into V naught, this value is 1000. So 4 into 1000 divided by root 2 into pi into Is. So Is is 10 by root 2, 10 by root 2 into cos 60. And then you can solve this one. 4000 by root 2 into pi into 10 by root 2 into cos 60. So 3183. 3183 watt. See, this is also one line question. It is also asking 2 marks. Same year, 2022. See, is it clear?
Yes, sir. 3183.09 watts.
Yes, 0.09. Correct. Okay, so I'm moving to the next question. See, this is a half controlled single phase bridge rectifier RL load. It is operated at fire angle and load current is continuous. Okay. So this is also the same thing. Continuous means continuously it is conducting. So this is full bridge with freewheeling diode. Okay. So already we have drawn this waveform. Again, I will draw the waveform again, not the circuit. So 0 to alpha, the
Sir,
freewheeling diode.
alpha by 2 pi answer.
No. See, so I will move to that. There I have drawn the waveform. 1 second. This is the waveform. So see, freewheeling diode is conducting from here to here and here to here. So in 2 pi of cycle, okay, freewheeling diode conducting for 2 alpha. Okay. So in what will the fraction? Fraction will be 2 alpha by 2
Pi.
pi. So it
So
will be
alpha by.
alpha by pi will be the answer.
Okay, sir.
Okay. This is I think the 2012 question I think. So this will be the answer. Okay. Now next question. So this question I think recent only 2017 question. This is. So see here semi-converter only circuit is given, but load is resistive. Here they are not
Zero.
meant. Yes,
Zero amp.
that will be zero. Why zero? Because load current is not
Load is
continuous.
pure resistive, sir.
That's why. If it will be inductive, then only this freewheeling diode will conduct. So ID3 will be 0. Okay. Is it clear to all?
Yes, sir.
If that
Clear, sir.
resistive load, there
Uh,
will be current exists, sir.
the load current will be there, but freewheeling diode current will be 0. ID3 will be 0.
Okay.
Sir, if RL load is here, then I3.
Then this will conduct.
Mm,
That
okay,
load
sir.
current, if this current will be continuous, then that current will come here. Okay. See, I will draw the waveform for this one. Output voltage will be like this: alpha to pi, and again pi plus alpha to 2 pi. Current also waveform will be like this only: alpha to pi and pi plus alpha to 2 pi. So since here no current is there in this section, so here current will be 0. The output current is not a continuous current. That will be a discontinuous current. So this will be the output current. This is the output voltage. Is it clear? Clear to all?
Clear, sir.
Yes, sir. Yes, sir.
So this is also simple question only. So can anyone tell what will be the answer for this one?
Option C, sir.
C. Okay. Output voltage will be always greater than equal to 0. Yes, voltage waveform will be like this. So this will be either greater than equal to 0, and output current will be greater than equal to 0. It's looking correct only. Output, see, some current will be there. Okay. So if output current will be 0 also, this one option is only. See, output current cannot be less than 0, cannot be less than 0, and voltage cannot be less than 0. Okay. So this is only the correct option. Correct only. Is it clear to all?
Yes, sir.
Okay. Okay. Moving to the next question. See, so this question I think I have taken from my notes. So what will be the IT1 RMS we have to calculate? So how we can approach in this kind of question? So I think alpha should be given. Let's say alpha is equal to 60 degree. Okay. So this L is large. L is large is given means what will be the output current? That will be the continuous. Okay.
Constant, sir.
So first we will write VO. VO will be Vm upon pi 1 plus cos alpha. So this Vm will be 200 into root 2 by pi 1 plus cos 60. Can anyone tell this value? 200 into root 2 by pi into 1 plus cos 60.
Sir, 135.047.
135.047. So what will be the output current? Output current will be 13.5.
Yes, sir.
13.504.
13.5.
So we have to calculate IT1 RMS. So what will the IT1 RMS? This is here. So T1 will conduct from alpha to pi. Okay. So IT1 RMS will be, then write as pi minus alpha by 2 pi into I naught. Okay. So this will be pi minus pi by 3 divided by 2 pi into I naught. Can anyone calculate what will be this value? So 3 pi means 2 pi by 3. So 2 pi by 3, how much it will be?
So 7.79 amps, sir.
2 by 3 divided by root 2. This will be the
7.79 amps, sir.
7.79. Okay, everyone is getting the same?
Yes, sir. Same, sir.
Okay, 7.79. So this will be the RMS current. You can calculate the average also. So next one more question is there, that is like whole, that will be whole thing will be there in that question, like input power factor, average and real and reactive power. So that will be the last question. I will explain that. After that we can meet in the next session. So 1 second. This, I think 2 questions are there. I'll do fast. Okay. So can anyone tell how we can proceed in this question? Just from given data, can anyone tell? Alpha is given, I naught is given, okay. IT1 average is given, okay. And we have to calculate the output power.
Sir, 120 volts peak value or RMS value, sir?
See, if nothing will be mentioned, that will be RMS value, okay. If something Vm sin omega t will be written in the question, then only we will assume that this is the peak value, okay. If 120 volt 50 like this kind of language will be written, then that will be by default RMS value, okay. So from the given data, how we can calculate the average power? Can anyone tell? For average power,
Sir,
what will
two,
be?
sir, 2 into 120 by pi into 10 amperes.
How 2 into
2 into 120
120
by pi
by pi
into I naught.
into I naught. How you have written this?
Here the output current is constant, sir.
Okay, but output current data is not given. Here thyristor current average value is given. Okay.
Okay, sir.
See, we have to, what is the output power? Output power is equal to VO average into IO average.
Yes,
Okay.
sir.
VO average we can calculate from the alpha. Vm upon pi 1 plus cos alpha is
Kasa.
VO average. What is IT1 average? So IT1 average will be, this is one diode, this and this is one thyristor, this is one thyristor. So what will be the IT1 average for this kind of circuit? Already we have derived. What will be this one? IT1 average will be T1 will conduct from which to which? T1 D2 will conduct again.
Alpha to pi plus alpha, sir.
Oh, 1 second. I think here I have done the mistake. This is diode only. D4 I have written. Na? So alpha to pi plus alpha. Okay. So IT1 will be pi plus alpha minus alpha by 2 pi. This one will be there. Is it clear? This value only will be there. Pi plus alpha minus. See, it will trigger at alpha. Okay. So alpha to pi. Again at pi, what will happen? This will do freewheeling T1 D4. Okay. Before here it will do. So we can say that alpha to pi plus alpha. So pi plus alpha minus alpha by 2. So I naught by 2. IT1 will be equal to I naught by 2. Okay. So I naught is, we have to calculate. So I naught will be 2 IT1. Is it clear?
Yes, sir. 20 amps that one.
So that 20 we have to multiply here. Okay. Bm by pi 1 plus cos alpha into I naught. I naught will be 20. So first we will see the information what is given. From that we can calculate the output current, and output power will be V naught average into I naught average. Okay. It clear? Clear to all?
Yes, sir. Yes, sir.
Okay. So one more question is there. Should I discuss that, or we can discuss that in next class? If you, all of you are agree, I will discuss that.
We can discuss, sir.
Okay. Okay.
Yes, sir, you can discuss.
Okay. Okay.
Continue, sir.
Okay. Okay. So in this question, all thing will come to 230 volt, 50 hertz. Okay. This is this kind of circuit, and I naught is 10 ampere constant current, and here it is given alpha is equal to 60 degree. Okay. So we have to calculate input power factor. So how we can calculate input power factor? First we need IS, then IS1.
IS1 by IS1 by IS.
So IS1 by IS into
Cos
cos
alpha.
alpha by 2. This will be the, so this is called distortion factor, and this is called displacement factor. Okay. In question they can ask distortion factor also and displacement factor also. Okay. Current current distortion factor, and this is called current displacement factor. Okay. So one by one we will calculate. IS1 will be 2 root 2 upon pi into I naught into cos alpha by 2, and IS will be pi minus alpha by pi I naught. So directly we can write IS1 by IS. One second. IS1 by IS will be 2 root 2 by
For the
pi.
derivative cos alpha by 2, no, sir. IS1 by IS, you said.
What?
In previous slide, you said IS1 by IS.
Where? One second. Where? This one.
Here, sir. Yes, sir.
So this will be the input power factor will be IS1 by IS into cos alpha by 2.
Yes, sir. Yes, sir.
This will be for all converters. So for all converter, we will do fundamental current, then source RMS current. What will be the displacement factor there? That will multiply here. Like for normal full bridge converter, displacement factor is alpha. So there will
Okay.
multiply cos alpha. But this one, we are getting displacement alpha by 2. Okay. See, coming to the question. So this only. One second. Where is the question? Here. So directly we can write here like IS is equal to pi minus alpha by 2 pi into I naught. So I naught will cancel. Okay. So what is the alpha value? Alpha is pi by 3. So we can write 2 root 2 upon pi into, this is 60, so it will be cos 30 divided by pi minus pi by 3 divided by 2 pi. So this will be 2 by 3. One second. See, this will be pi minus alpha by 2 pi, or it will be pi, not 2 pi. Okay. For source current, it will be pi. For thyristor current, it will be 2 pi. Okay. Is it clear to all? Already we have derived that thing. For source current, it will be pi minus alpha by pi. Already we have derived. I will show you. So here we have derived pi minus alpha by pi. This is the source current for all. Okay. And thyristor current, somewhere it will come by 2 pi. Okay. Coming to the question. One second. So here it will be 2 by 3. So 2 by the 3 will go at top. So it will be 2 root 2 upon pi. Here we can write root 3 by 2. 1 minus 1 by 3. So 3 minus 1, 2 by 3. Root 3 by root 2 into root 3 by 2. Okay. So this root 2 and this 2 will cancel. So this will be 3 by pi.
Sir, 0.011, sir.
Is 3 by pi you are getting? Final derivation 3 by pi you are
Sir,
getting? 0.954 it will come. IS1 by IS will come as 0.954.
yes, sir, yes, sir.
IS1 by IS will be 0.9549. Okay. And what will be the cos alpha by 2? This is displacement factor. Cos alpha by 2 will be cos 30, will be 0.866. So input power factor will be IS1 by IS into cos alpha. So 0.9549 into 0.866. I think this type of question they have not asked in GATE till now. Maybe they can ask, like the upcoming years, they can ask this kind of question. Okay. So you should be ready with all this kind of question. So 0.9549 into 0.866. How much? 0.826. So this is the fundamental input power factor. It clear to all?
Yes, sir. Clear, sir.
Okay. Similarly, we can derive the real and reactive power. So real power and input reactive power. Okay. So PIN will be Vs into IS1 into cos alpha by 2. Okay. And QIN will be Vs into IS1 into sin alpha by 2. So you can write one by one here. What is the Vs value? 230. 230 into 2 root 2 by pi into I naught how much? I naught is given. I naught is not given. 10 ampere here. So 10 into cos 30 into again cos 30. Is it clear? This one IS1 value here to here, and this is cos alpha by 2. This is Vs. Is it clear to all? Can anyone reply?
Yes, sir. Clear, sir.
So into cos 30 into sin 30. Okay. So Vs IS1 sin alpha by 2, this will be a reactive power. This will be a real power. Okay. See, some fundamental source voltage is there. With that, some fundamental current is flowing. So with this one, what will be the injected real power and injected reactive power from the source side that we are calculating here. Okay. So this value, can anyone tell how much we are getting? Second. And this I'm going to calculate with, so this should be verified with V naught average, I naught average. Okay. This value should match with this one. Like input real power should be equal to output real power. So V naught average into I naught average. Both should match. Okay. So this one I am calculating. All of you can calculate this one value. So V naught average is equal to 2 Vm upon 2 pi into 1 plus cos alpha. Okay. So Vm 230 into root 2 at 2 pi into 1 plus cos alpha is 60. Okay. Cos 60 into 10. So this real power should match this real power. Okay. I'm calculating this one. So 230
Sir, output power is 1553, sir.
15 is correct one. So this one also should come same.
Yes, sir. 1553.
Both you have calculated this one and this one. You calculate the below one also. 230 into root 2 divided by 2 pi into 1 plus cos 60 into 10. No, some mistake is there. No, here 2 pi will not be there. Here pi will be there. Vm upon pi. VO average will be Vm upon pi 1 plus cos alpha. Already we have derived. Okay.
Same, sir. 1553.
See. So 1553.04. Okay, so if they are asking like some data will be given, if like they are asking what will be the real power, reactive power, sometimes we can calculate with fundamental also. Directly we can, so whatever will be the easiest for as per data given, that you can use. Okay, is it clear to all? So that's why input real power should be equal to output real power. Okay, and that source current formula we can derive with this one also, Vs into Is1 into cos alpha by 2. This should be equal to V naught I naught. So from here also, if you will derive Is1 value, Is1 will come as 2 root 2 upon pi into cos alpha by 2 into I naught. So like I have done the power balance in first class, you can apply this one, and final value we will get Is1 will be, fundamental will be 2 root 2 pi cos alpha by 2 into I naught. Is it clear? You can derive this with yourself. Otherwise, if you will tell, I will derive this. It's just power balance. Input power should be equal to output power. Is it clear?
Yes, sir.
Okay. So what you can do, like you whatever I have taught till now, if you'll solve questions by yourself, like you can select questions from previous year gate and all, with this one, if you will try to solve, then you will get more confidence. Okay. And if you will be more attentive, like if you'll ask more doubts, then your concept will be more clear. So you should also think, like you should come with some tough questions, like why this is happening, why this is not happening. Then it will be more clear. Okay, like whatever I'm teaching, you should do some homework before, like after the class, next class. So upcoming classes will be more critical. See, if I'll come up with three phase, okay, so your single phase should be clear. So what my plan is, I will cover all three phase, like 6 pulse and 3 pulse. I will explain step by step so that it will be easy to all of you. Okay. Some people are there facing trouble in three phase, but that is not a tough key thing. I will explain that in easiest way. Okay. So after attending all this session, you can solve all previous year questions easily. Like whatever the rectifier questions are there previous year, all of that you can solve easily. So you should go through those previous year questions and try to solve that. If you are facing any doubt, any previous year question, okay, so that you can post in group also. I will come up with that question in the next class.
Sir,
Now, yes, you can ask.
in that transformer question is there, no, sir?
Yeah, okay,
ID.
okay. Yes, you can ask. One second, I'm going to that question. This one, you can ask.
Sir, let me assume that there's a ripple free current, sir. How we have to process, sir? How we have to
See,
solve that
see,
question?
this is ripple free course current.
Yes, sir.
I naught is ripple free. Okay. So I naught is ripple free means this will flow in this one. So alpha is given, R value also should be given. See, R value should be given. Then only we can calculate I naught. Otherwise, I naught value should be given. Okay. Either R should be given, like this is, let's say RL load, and R value I'm assuming as 10 ohm. Okay. So we can calculate the average value. What will be the average voltage? So Vm upon pi 1 plus cos 90. Okay. This will be the average value. So we can calculate the average current. Average current will be V naught upon I naught. V naught upon R. Is it clear?
Yes, sir.
So I naught we have calculated. So where freewheeling diode will conduct, freewheeling diode will conduct in this portion. Okay. In this portion and this portion. So the one second, I'll just omit this one. So this
Sir,
is
that one starts from 90 to 270 degrees. No, sir.
no.
Alpha.
See 90-degree T1. See thyristor T1 is triggered at 90. See here 90. So alpha is
Yes, sir.
90. Okay. This T2 is conducting at pi plus alpha. So pi plus alpha means 180 plus 90, 270. Okay.
Yes,
So
sir.
it means we can say that alpha is equal to 90. Is it clear?
Okay, sir.
So this I naught we have calculated. I naught we have calculated means what is the RMS value of D3? So that will be 2 alpha by 2 pi into I naught. I D3 RMS. Already we have so alpha by pi already we have got. So under root alpha by pi into I naught. So this will be the RMS value of the D3 current. Is it clear?
Yes, sir. Here, turns ratio is not in use, sir, for
See,
that one.
no. So this will be used only. See, here
10
voltage,
is to 1.
here voltage will take. So 230, it will come, divide 23 will come here. This voltage we have to
Okay.
take. It
Okay,
will be
okay,
10.
sir.
This will come. See, here whatever voltage will be here, that only contribute the output. Okay. Is it clear?
Yes, sir. Yes, sir. Sir, if that there is a midpoint transformer means
That will be
12.4, sir. 12.5.
see,
11.5.
whatever the value will come across this point and this point, that only we will consider. Okay.
Okay, okay, sir.
Okay. So thank you all. I will recommend you all of you, like, you should solve some previous year questions based on full, like either full bridge or semi converter. Both type of questions you can solve. And next class I will cover up these two parts only. I will not jump on the three phase. I will come up with more questions on these two parts. First part will be like single phase full bridge, and this one semi converter and some half bridge also. So some various questions. Next class I will discuss mostly questions based on this all parts. Okay. So that will be a revision kind of thing. After the next class, next to next I will start three phase. Okay. Okay. So thank you all. We'll meet in the next class next Monday. So all other sessions are going on, other subjects.
Yes, sir. Going on, sir.
Okay. Okay. So try to, like, why, what is the benefit? Like, try to ask more doubts to all TAs. Like, then it will be more clear to all of you. Like, this live sessions means your personal doubt should be cleared. Like, just like some other tutors are also teaching, but they will not clear your personal doubt. Okay. But here, whatever doubt you have, that you can ask one to one. That is the main benefit here. Okay. So thank you all. Next session will meet on the next Monday. Thank you.
Thank you,
Thank you,
sir.
sir. Thank you, sir.